Welcome to the online lectures for software engineering. In today's class, we'll be studying design concepts. Now, design concepts answer, it is a big answer and it is important for 5 marks. So what is design concept? Design concept, they are going to help the designer for the foundation for developing more sophisticated designs that can be applied. So within the design concepts, there are nine different concepts. By making use of those 9 different concepts, it is going to help the designer so that you have a foundation from which you can develop more sophisticated. What is sophisticated? Sophisticated means advanced designs. These can be developed. Now come, these are the 9 different design concepts that we'll be studying today. Now the first one is abstraction. Now what is abstraction? Abstraction means the level of detail. Now within abstraction, whenever you're considering a solution to any problem, now the solution of the problem, it can be represented in 2 levels of abstraction. You can either have the high level of abstraction or you can have the low level of abstraction. Now what happens within the high level of abstraction? Within high level of abstraction, you're going to define the solution in broad terms. The solution is going to be defined in broad terms in high level of abstraction. Whereas whenever you are defining the solution to the problem in lower levels, it is you're going to give more detail about that particular problem. Now within this abstraction, you're going to have 2 different types of abstraction, procedural abstraction and data abstraction. Now within procedural abstraction, it is a sequence of instructions that has limited function and special details are suppressed. Now let me explain you this with the example. Now within this procedural abstraction, we are considering the term open for the door. There's example of a door. Now within this example, we're taking the word open. Now this open implies a long sequence of procedural actions. Now for opening the door, first you have to walk to the door. Then you got to reach out to the door so that you can grasp the knob. You can grasp the knob. Then next is turn the knob. You're going to pull the door and then you have to move away from the door. So these are the sequence of steps that need to be followed whenever you're considering the term open for door. So this is procedural abstraction. Now we'll read the definition again. It is a sequence of instruction that has limited function and special details are suppressed. Now this different limited functions, what were these limited functions? This were like walking to the door, reach out, grasp the knob, turn, pull the door, then move away from the door. So this is your procedural abstraction. The next one is data abstraction. The second type one is data abstraction. Now data abstraction, it is a named collection of data that is going to describe the data object. Now within this data object, what we are going to see is here within data object, within the context of procedural abstraction, that is we have studied the term open for door within procedural abstraction. Here we are going to study door within the context of procedural abstraction. So within this door, this data abstraction for the door, it is going to encompass a set of actions like the manufacturer of the door, the model type, the swinging direction, inwards, outwards, the lights are there for the door, the type number, the weight, what is the opening mechanism. So this is your data abstraction. Now within this data abstraction, this you can say that data abstraction, it implements as a data structure. So coming on to the definition, it is a named collection of data that is going to describe your data object. What is your data object? Your door here is your data object. This is your data object. Here you are describing your data object, that is the door. So this is your procedural abstraction and your data abstraction. Abstraction is the level of detail that is given for the solution of any problem. The next one, the second type of concept is your architecture. Now, what is architecture? Architecture gives an overall structure of the software. Architecture gives you an overall picture of the software. That is how the software is going to look like. Or you can say how the different components of the, this is the first definition. And the second one, you can say that how the different program components are organized. These are your two definitions for architecture. Now, within this architecture, the architectural design can be represented using one or more different models. So what are those different models? The first one is structural model. This structural model, it is an organized collection of program components. It is an organized collection of different program components. That is how are your different components within the software, how are they organized, that is going to be identified when you go for structural models. The next one is framework models. Now, what are framework models? What is framework? Framework gives you the entire skeleton of a particular thing, how it is going to look like. Now, within this framework models, they increase the level of abstraction. This is going to increase the level of abstraction. Now, how it is going to increase this level of abstraction? By identifying if there is any repeatable architecture. Now, repeatable architecture, when are you going to find a repeatable architecture? When you are developing a similar application. So here the different architecture, they can be reused. Now, whenever you're reusing, it is going to save your time and cost. So that is the second model, that is the framework model. The next one is your dynamic models. Now, what are dynamic models? Dynamic means it is going to tell you the behavior. What are the different behavioral aspects of the program architecture? How this system is going to behave to a specific environment, that is going to be identified by the dynamic models. The next is process models. Now, within the process model, these are going to focus upon the design of business. That is, whenever you're designing a particular product, you are going to identify how it is going to affect the business, whether you're going to have profits, whether you're going to have losses, how you're going to meet the ends, that is going to be identified. Now, this first thing is you're going to focus upon the design of the business, or the second thing is you're going to identify and focus upon a specific technical process. Now, this technical process, it means that this technical process, it need to be accommodated within the software. So process models have two tasks, whether it is going to focus upon the design of the business or any technical process that need to be accommodated within the software. Then the next one is functional model. Now, this functional model, this can be used so that it represents a functional hierarchy. It represents a functional hierarchy of the system. Now, function hierarchy means, now you might have one specific task. Now, within the specific task, you might have a list of different tasks that can be implemented. So that is your task hierarchy. So there are 5 different models. Whenever you're designing an architecture, it can be represented by making use of either one or either many models. You can use structural model, framework models, or dynamic functional models, or process model. Based upon your requirement, you're going to use a specific model. Coming on to the third one, that is pattern. Now, what is a pattern? The pattern, design pattern, it is going to describe the design structure. Now, whenever it is going to design, whenever you're going to focus upon a design structure, this design structure, it is going to use to solve a design problem. Now if suppose you are designing your room, now a specific design can be implemented if you've got a window in your room, or another design can be implemented if you've got a balcony in your room. So you're going to identify a specific design structure that can solve your design problem. And patterns, they also, these patterns, you've got different forces that is also going to affect the patterns that you're using. So the intent of pattern is to provide description that is going to enable a designer to determine these three things. So what are the three things? Whether the pattern is applicable to the current work. Now as I've given you the example, if you've got a window, so whether this particular pattern, it is going to focus upon a room that has got a window, whether it is applicable to the current pattern, that will be identified. Then whether the pattern can be reused. Now whether the pattern can be reused means it is going to decrease your cost and time, both of them can be decreased when a pattern can be used. Now if suppose you are implementing a new pattern, so you're going to identify whether this pattern can be used somewhere else within the future. So whenever a pattern can be used, you're going to store it accordingly with the details provided. Then the third one is whether the pattern can serve as guide for developing a similar but functionally or structurally different pattern. Now within this, you're developing a similar pattern means, suppose you're designing a particular application, a food delivery app. Now whenever you're designing a food delivery app, you have different multiple food delivery apps. So this food delivery apps, this can be used as a guide now to study how this food delivery app was developed. Now if you're making another app that is similar to it, it is going to be a structurally different pattern. You're going to have different um, aesthetics of the particular software, but it is going to have some similar features. So based upon that, these three things can be used whenever you're applying the pattern. So whether it is applicable to the current work, whether it is reusable, or it can be used as a guide to study a similar software. Then the next one is modularity. Now, what is modularity? Modularity means you're breaking down the software into different parts. Now, these parts are called as your modules. Now, why are you breaking down the entire software into different parts? You're breaking down it into different parts so that you can easily work on them. Now, when these different parts are done, when you work on them, at the end you can integrate these different parts and you can form that into this main software. So this modularity, it is a single attribute of software that allows a program to be managed easily, so that this particular thing. Now, take this graph, you've got the cost or effort and the number of modules on either of the axes. Within the x-axis, you've got number of modules and the cost or effort within the y-axis. Now, within here, we can focus that for this particular line, as the number of modules are going to increase, the cost or effort is going to decrease. This is your first curve. Whereas for the second curve, you can see that if the number of modules are going to increase, it is also going to increase the cost. It is vice versa of this. So within this, you're going to identify a region of minimum cost. That is, if suppose this is a particular software. Now, ideally, this particular software, if suppose it can be split into three different parts. So this is an ideal. You're not going to split it into more parts. That is, for this particular software, you're not going to split it into 3, 4, 5, 6. So if you're splitting it into different parts, as we are splitting it into different parts, now when you want to integrate them, that is when you want to join it into this entire thing again, there is within this, when you're integrating this software, you have some specific cost here, how you're going to join this particular software. So within this, the cost is going to increase. So you're going to identify a region of minimum cost, that is, you're going to split it into number of modules into some modules that is going to give you a minimum cost. So this is modularity concept. The next concept is information hiding. This is the fifth concept. Now, what is information hiding? Information hiding, this we within the previous slide we have studied, we are going to split the different software into different modules, that is different parts. Now, when you've got a specific module, this is your module, you've got some data within a particular module. Now, this data should be inaccessible by another module. It should be accessible by another module that has no need for this type of information. Now this information hiding, this is going to give great benefits whenever you're making any modifications within the software. Now making modifications within the software and later within the testing phase. Now how it is going to give you a greater benefits? Now when you have got information hiding, that is one module is unable, there's one module, there is another module. This module is unable to access data that is stored within another module. By this you are safeguarding the information and you are avoiding any accidental errors within the software. Now what are these accidental errors? What happens sometimes when you write a particular program, there's particular program, within the particular program you might have made error within the first line. It is going to reflect errors within the different lines. So these are your errors. So these are your accidental errors. If you're hiding info, if you do not have the concept of information hiding, making changes, if suppose this data I'm making any change within this data, I'm changing this data. So if suppose another module is able to access, it might even change the data that it has. So this is in some another error within the software. So to avoid these accidental errors, you should have the concept of information hiding to avoid accidental errors within the software. Now if you have accidental errors, then again within the testing phase also, this is also going to create problem. The next concept, the sixth concept is functional independence. Now, functional independence, what is functional independence? It is a direct outgrowth of the concept of abstraction. That is the first concept that we've studied. It is similar to abstraction, modularity, and information hiding. It is similar to these three concepts. That is, you can say, it is made up of these three concepts. Now, what is functional independence? A module that has got one single task or function that has little to no interaction with other module is known as functionally independent module. Now, if we take an example, if an assignment is being given, the one particular student in your class, he completes the assignment with some help with his friend or without any help from his friends. So that is functional independent. That particular person is functionally independent. He can work on his own. Based upon that particular assignments, everyone is going to copy the assignment. So that is, if the first person that is doing the assignment, that is called as functionally independent. A module that has one single task or function that has little to no interaction. He might have little interaction or completely no interaction. That is called as functionally independent module. Now this function independent module, this function independence, this can be achieved by two other concepts, that is cohesion and coupling. These are the two concepts through which you can achieve function independence. Now what is this cohesion and coupling? Now this cohesion, it is a extension of information hiding. As we've studied functional independence, it is the extension of these three things, whereas cohesion is a direct extension of functional of the information hiding concept. Cohesion is a direct extension of the information hiding concept. Now this cohesion, what is cohesion? Cohesion is an indication of relative functional strength of a module. Now this function strength, now the cohesion means the particular software cohesion module means a single task is performed with little to no interaction. It is going to have this same definition. Whereas coupling, it is indication of relative interdependence among the modules. Now for this cohesion, it is the degree to which a module performs one and only one function. Whereas coupling, the degree to which a module is connected to another module within the system. Now cohesion means one particular module is doing one job without help from another. Coupling means how much it is dependent on another module, how much it is connected, whether it is taking input from different components or not, how much it is connected with the other modules, that is coupling. So whenever you are designing a software, whenever you're designing a software, you're going to strive for high cohesion, that is one particular module needs to perform one task, and you're going to strive for low coupling. Low coupling means the one different modules they should not be connected with multiple number of modules. They might be connected with one module or two based upon the task that is to be performed, but whenever you're developing a module, this coupling should be low as possible. The next one is refinement. What is refinement? This first thing, refinement, it is a top-down approach. Now what is going to happen within this top-down approach? Now within the first concept we studied, the abstraction. With an abstraction, I've told you, you're going to first begin at high level of abstraction, and then you're going to go to the low level of abstraction. High means you're going to give the solution to the problem in broad terms, whereas in low level of abstraction, you're going to give a detailed description to the problem. So this refinement, you're going to give more detail at each increment. That is how much you're refining the module, you're going to give that level of information. More detail is given at each increment. Now refinement is a process of elaboration. That is, elaboration means first you're defining a particular solution in broad terms, then you're giving more and more detail. Now what happens within this elaboration? A program is developed by successively defining it into procedural details. Now what is this procedural details? Now within this, it means that you're going to decompose a statement of function. Now what is a statement of function? It means the data, sorry, it means the statement of function means the description of information. You're going to decompose a statement of function in a stepwise manner until the program language statement are reached. That is until you get out the programming level statement, what you are going to write within the line of code. Till then, you're going to decompose the statement. That is called as refinement. The next one is refactoring. Now, what is refactoring? Refactoring means you are reorganizing the code so that you can simplify the design. That is called as refactoring. Refactoring is the reorganization technique so that it can be used to simplify the design, or you can say that simplifying the code of a particular component. Now this refactoring means that you are changing the internal structure. You're making changes internally, but it does not affect the output. Output is going to be the same. The output is not affected, whereas you're just going to enhance the internal structure. Now, when a software is refactored, the design will be examined for different redundancies. Now, what are those redundancies? It will be identified for different redundancies. The first redundancy is going to be, you're going to identify if there is any unused design element, that is, you've kept it within the line of code, but those are not implemented, so you can remove them. So you're enhancing the internal structure. Then the next one is, second one, you're going to identify if there is any inefficient or unnecessary algorithm. Now, inefficient means it is not giving you the exact output. The accuracy is not correct. That is inefficient. Unnecessary means you're not using that particular algorithm. You're going to identify this thing. Then the third type Third thing that you're going to identify is if there is any poorly constructed data structures. Poorly constructed, or you can say any inappropriate data structures are there, you're going to identify those. If poorly constructed, you're going to define those data structures. Again, inappropriate means if they are not used, you can remove those data structures. Then the fourth one is you're going to identify if there is any design failure. If there is any design failure, you are going to correct that so that you get a better design. So within refactoring, these four steps are going to occur. Sorry, these four steps are within this. You're going to identify these four different redundancies within the refactoring phase. Now, within this different concepts, these can also be asked for 2 marks. That is, what is information hiding, what is cohesion, what is coupling, what is refactoring. These questions can be asked in exam. Now, the next one is design class. Now, within this design class, as you're going to develop the design model, the software team is going to define different design classes. Now, these are 5 different design classes. The first design class is user interface class. Now, user interface means how the it is going to focus on HCI. What is HCI? HCI means human computer interaction. What is the ease of interaction that is going to be identified within the first phase, that is the user interface classes. Then the next one is business domain classes. Within the business domain classes, it is going to refine the analysis classes. Now, refining the analysis classes, this means now within those design classes, whenever you're designing the whenever you're developing the design classes, 2 things might happen. You are either going to refine the analysis class. Now, refining means we just now studied. Refinement is giving more and more detail to the particular software. You're going to refine the analysis class by giving specific design details. And the second one is it can be used to create a new set of design. So whenever you're building the design classes, 2 of these things are going to identify to be they are going to be executed. Yeah, either you're going to refine the analysis classes, that is you're going to give more detail about the analysis class, or you're going to make use of different design classes, that is you're going to make use of another thing so that it can help you execute a specific business solution. Now we'll take an example for this within this design concepts only. Now, for for the user interface classes, you're going to focus on HCI, as I told you, the human computer interaction, the ease of interaction, how you're going to communicate with the software. What type of interface is given, whether there is a graphical user interface or you're going to have keyboard commands, mouse commands, what is being used, you're going to identify that. Now, within this business domain class, you're going to refine from the analysis class. Now, refinement of analysis class means you're going to give more detail of the analysis class. That is, now classes, what is a class going to have? It is going to have different attributes that is going to define the class. So you're going to identify the different attributes and the different services that is required to implement some element of business domain. That is, the business domain means you're going to focus upon the different profits, the different losses, how are the margins going to be achieved, that is going to be identified. So this first one was refining the analysis class. This is the first task that the design classes do. Whereas the second one was you're going to create a new design class that can be used to implement a business domain. That is similar to this process classes. Now it is going to implement the same business abstraction. Now within a business with the different profits and losses, you're going to give more level of detail upon the different profits and losses, the different margins, how you're going to have the software being implemented, how you're going to market it, how it is going to increase the sales, what are the different profits that you're going to achieve. So this is used to implement this business abstraction that is required to fully manage your business domain class. So this is your first and second steps that are used within the design class. Then the next one is persistent class. Now persistent means after you've executed, now suppose you're editing a particular video or you're editing a particular image. Now after editing your specific video or image, you are still going to have the non-edited version with you. So that is your persistent classes. It represents the different data stores. Now what is a data store? It as example is a database that will persist means it is still going to exist beyond the execution of the software. That is, after this program is being executed, you're also going to have this your existing file. It is still going to remain. That is persistent classes. The next one is system classes. What are system classes? They implement the software management, how you're going to manage the software and how you're going to control the different functions of the software. Now these two things are going to be used so that you can identify how you're going to operate the system and how you're going to communicate with the environment. What is your environment? Environment is the outside world. So these are the different design classes, 5 different design classes. With this, we have completed 9 different concepts of design class. Now there is an answer that is important for 5 marks. So you need to write accordingly. Now for design classes, you can write down only the side headings. Then the next one is characteristics of design classes. This can be asked for 2 marks or for 3 marks. Now within the characteristics of design classes, these are the 4 characteristics of design classes. Complete and sufficient. Complete and sufficient means you're going to have different classes. Now this class needs to have information. This information should be complete. Now complete and sufficient means the information that is there for the software, it should be sufficient so that it is the intent of the class can be achieved. The information should be sufficient so that the intent of the class can be achieved. Then the next one is primitiveness. Now what is primitiveness? Primitiveness means each and every method that is there for a particular class, method of the class, it should focus upon one service of the class. It should not have multiple services. Then the next one is high cohesion and low coupling, where this is one we have already studied within the previous slide. Now what happens within cohesion? Cohesion means it is the degree to which a specific module is going to perform only one function. That is high cohesion. Then the next one is low coupling. Now within this low coupling means that how much, or you can say again, the degree to which a module is connected to other modules. So the 4 characteristics of design classes are: it should be complete and sufficient, it should be primitive, it should have high cohesion and low coupling. So these are the characteristics of design classes. With this, we've completed the design classes. There are 9 different concepts. For the 9 different concepts, you're going to write it for 5 marks. If asked for 10 marks, you can write for 10 marks. Based upon that, you're going to write. So a quick recap of the different design concepts. With an abstraction, abstraction is the level of detail that is given to describe the solution to the problem. It can be a high level it can be high level of abstraction or low level of abstraction. Now within this abstraction, we have studied 2 types of abstraction. You're going to have procedural abstraction and you've got data abstraction. Within procedural abstraction, it is going to imply the different functions for a different functions, whereas within the data abstraction, it is going to focus upon the data object. It is going to describe a data object. The next one is architecture. Now within architecture, we have studied that within architecture, architecture is going to refer to the overall structure of the software architecture, or how the components are arranged, how the components are organized. Now within architecture, we have studied there are 4 different architectures, 4 to 5 different architectures over there: structural models, framework models, dynamic models, process models, and function models. The next one is patterns. Based upon a particular pattern, now the pattern describes a specific design structure that is used to solve a particular problem. Now, why are these patterns used? Whenever you're going for a pattern, this pattern is going to help the designer to identify whether the pattern is whether the particular pattern, whether it is applicable to a particular solution, whether it can be reused, or whether it can be used as a guide. So these are the 3 things that the designer can know by making use of patterns. Then the next one is modularity. Now what is modularity? Modularity means you're going to divide the software into different modules. Now you're going to design this, you're going to split the software into different modules. Splitting it into, as the number of modules increases, the cost is going to decrease. Now as you're increasing the number of modules, you also need to focus upon the cost of integration, how you're going to combine the different components. It is also going to give you the different costs. So here you're going to focus upon a region of minimum cost. You're going to focus upon minimum cost, so that it is your modules are divided into a limited number of modules and they can be integrated. Still, you should be able to achieve the less cost. Then the next concept is information hiding. Now what happens in information hiding? You're going to have different modules. The data that is stored within a module, it should be inaccessible by another module. It should be inaccessible by another module that has no use of such type of data. Now by making use of information hiding concept, you can avoid any type of accidental errors when you're maintaining or testing the software. The next one is functional independence. Now what is functional independence? Functional independence, it is, first we've studied that functional independence, it is an outgrowth of abstraction, modularity, and information hiding. It is outgrowth of these 3 things. Now within functional independence, this can be achieved via 2 concepts. What are those concepts? It was cohesion, the degree at which a particular module performs only one task, and the next one was coupling. Coupling means how much a software is connected, how much one module is connected with another module. Whenever you're designing software, you're going to focus upon low coupling and high cohesion. Low coupling and high cohesion. Then the next one is refinement. Now what happens in refinement? It is a top-down approach, and within this top-down approach, it is you're going to elaborate the different detail. That is, you're going to give more and more detail at each iteration. That is your refinement. Whereas the next phase is refactoring. Now what happens within refactoring? Refactoring means you are going to simplify the design without changing its functional behavior or without changing the output. So that is your refactoring. Then coming on to design class. Now within this design class, whenever you're implementing the design class, it can either do the two tasks. The first task was it is going to refine the analysis classes. What does refinement means? Refinement means you're giving more and more detail. You're going to refine the analysis class so that you can identify or you can enable classes that can be implemented. And the second one was you're either going to create a new design class. You're going to create a design class so that this can be used to implement a business solution. Within this, we have seen the business. First, we're using the business domain class. For that, we are using process class, implement a business class. So there's an overall description for design class. Now within design classes, we have studied user interface class, the business domain class. For supporting business domain, you've got process classes, then persistent classes, where data is going to be stored beyond the execution. Then you've got system classes that are used for managing and controlling the function. So these are the different design classes. Now for architecture, I did not write the different architectures. Okay. Now within this architecture, the different architectures that we've studied were for architecture. You can have structural models that is going to give you the different, it is going to represent the different program components. Then you can have your framework architecture. Within framework architecture, you're going to identify any repeatable architecture is there or not. Then dynamic models, it means that what is the behavior of the software. Then process models, this process models are going to focus upon a specific technical process that can be embedded within the software, or it is going to focus upon the designing of a business domain. Then the last one is functional models. Now this functional model, they are going to represent a functional hierarchy. Now for this architecture, you can either use one model or you can either use multiple models for defining an architecture. So with this, we finish the design concept that is important for 5 marks. That's the end of the class. Thank you.